Welcome all of you. So this is our 11th week session on the molecular rearrangement and reactive intermediates in the organic synthesis. And we will discuss here some of the problems based on the week 11 topics covered by the professor. So before moving to the problems, so I would like to take any doubts. If you have any doubts regarding the topic which are covered in the week 11, or in this course that we can discuss before moving further. So please stop me in between if you have any doubt, so we can discuss that one, and then we'll move toward the some of the sample problems. So I have taken some of the sample problems, and so I'll just reshare the screen. So this is the first question. So if you look at the question, so the question is, what is the major product formed in the following reaction? So here we have the starting material, which is the benzene ring with the uh, conjugated double bond and the PTSA as a catalyst. And if you look at this benzene ring, which has a S double bond O, PR stands for isopropyl. So here it is N propyl, so that's just alkyl chain CH2, CH2, and the CH3. So that's the alkyl side chain. So what happened when we add the PTSA? That's the para-toluene sulfonic acid. This is kind of a weak Lewis acid, and it provides the acidic proton to the compound. So what happened in this reaction? So if you look at the reaction mechanism, so this S double bond O get protonate in presence of the PTSA. This is the alkyl chain, and if you look at the remaining part of this benzene ring, this will be like this. And if you look closely at the double bond present in the starting material, so this double bond, so this is generally the olefins are electron rich, so they can attack on so the attack takes place in this fashion. So I'll go by source, not this way. So if you look at the mechanism, so we'll go by this mechanism. So this is the bond polarity. Okay, the protonation of this double bond takes place not on the phenoxide. So first step is, so this is the proton which is attacked, and now the carbocation form at this tertiary position. So this O minus attack on this carbocation, and it forms the 5-member ring. And further upon deprotonation, followed by the SO bond cleavage takes place. So it gives the S plus cation, and which on the, so this now will converse group it converted alcohol, which now attacks on these carbon. So it gives the formation of this product. So this is somewhat complicated reaction mechanism. So if you look at if I just draw the mechanism stepwise, so in place of the PTSA, that's the source of acid. So this will be the negative. This I'll just write the bond polarization between the sulfur and oxygen. So this will be bond polarization looks like this, and also in parallel, the reaction of this double bond, so which abstract the proton. So if you look at this bond, so this proton comes from the PTSA, right? That's the CH2H. That's the CH3. Now this negatively charged attack. So once this double bond abstract the proton, at this carbon, there is a stable tertiary carbon takes place, formation takes place, which is then get attacked by the O minus of the sulfoxide anion, and this step will be this is the intermediate one is getting formed. Then the second intermediate will be the this is now the five-membered ring formation, right? So this is the carbon which has the two CH, one CH3, CH3 groups, followed by, and this is the part of the benzene ring. If you look at here, this is the CH2 and CH3 that will be remain there. And since there is a positive charge on the sulfur, one of the proton from the CH, I will write VCH2 in the form of CHH. So better for better understanding, this will be CH, and there is additional one proton. And this is the ethyl group that I will write in the form in this form. So this proton is now get abstracted, followed by this CH2S double bond formation, and parallelly this bond get cleaved, which again abstract the proton. So this is the proton that get abstracted. So we get a product. So this is the product we get in this step. So this will be S double bond, and this is ethyl group. Now here there is this is the group getting formed. Now if you look at the structure, so this S double bond S that will be the positive charge remain same because we have parallel cleaved although double bond correspondingly, but parallel we have cleaved this OS bond also. So this lone pair on the oxygen further attack on this part. Further, it gives the formation of the, and along with this, the bond pair of electron get delocalized on the sulfur. So the positive charge on sulfur get neutralized. So overall, so with this benzene ring, there is now this the sulfur, and this part will remain same. So this was the oxygen. Now this I will just draw this carbon center here. So which is which has the ethyl group and oxygen, which is as it is. So this is the product is getting formed in this reaction. So if you look at the correct options among the available, so option A is the correct option here. So one might also think of attack in this fashion. So let's say uh, the proton abstraction takes place by this manner, but further the course of reaction doesn't go by abstract. Let's say if the bond polarization takes place in this fashion, so this is the positive and this O now is negative, which abstract the proton from the PTSA, and this will be O H, and this will remain same. Now the positive charge will be on the sulfur. But if you look at the reaction, so reaction doesn't proceed further. So by this mechanism, the reaction won't work. We need to, so the proton abstraction, not by the S double bond O bond. So the proton is affected by this olefin part. So this olefin part attract the proton from the PTSA, and which form a stable carbocation. So that's the carbocation form here. So if you look at here, this is the carbocation getting formed. So we can note down the mechanism from this slide. So I will move to the next question. So this is the second question, and I think this same question that we have also discussed in the last previous session video. So what is the major product forming the following reaction? So this is the if you look at the reagent combination, this is the DMF and the POCl3. They are used for the formylation reaction, and formyl group, that's the C double bond O H group addition. So this group addition takes place, and this addition takes place on the center on which the electrophilic substitution reaction takes place. So let's say if you have substance like this, and if you do the formylation reaction, this reaction will work on the ortho position of this hydroxy group. If you have some substance like, let's say, like this, so on this formulation takes place, C double bond O H at this point. And if you look at the substrate, the formylation reaction takes place by, so I'll just write down here the relocalization W. So via this carbon, that's the C3 carbon, the formylation reaction takes place. So the option B is the correct option here. So if you want to look at the detailed reaction mechanism, so this is the same that we seen in the last time. So that's the DMF, dimethyl formide, and when it react with the POCl3, it forms the iminium cation, and this is the active species used in the formylation reaction. So when this iminium cation react with the our aromatic compound, it leads to the formation of formylation. So you can look at the detailed reaction mechanism through this slide. So we take the next question, and this is the same question that based on the concept which have one of the question we have seen earlier in the last week. So the major product form in the following reaction, and if you look at the reaction sequence, so we have the aldehyde group, and this is the one of the name reaction. When aldehyde react with the CBr4, PPS3, and DCN, so it leads to the formation of PHCH2. Now in this case, CH2. So there will be so if I just draw in this form, so the pH, so it will be easy for write down the intermediates. Br and the Br, and then in place of the butyl lithium, what happened? So this butyl lithium lead to the formation of, so Br, and here there will be a in the first step there will be a negatively charged at this position. So LIBR get removed, and later there is a pH, CH2, 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 and so that's the triple bond formation. Sorry, not like this. So one carbon will be less in the product. So write down the correct geometry. So this will be the product in the reaction. So this is the product of the first step. So and the upon second step, this product is getting formed. So we need to identify the final product. So the final product is option C is the correct product. So if you use the reaction condition one, so it gives the this product, and on this one, if you put the reaction condition two, that's the butyl lithium in two equivalent, we get the this product. So here is the right. So you can see this is the product form in the final product. So option, which is option C. The next question is the major product form in the following reaction. And we have the starting alpha bromo ester. So that's the alpha bromo ester, and reaction is with the POET thrice. So O ethyl. So that's the reagent, and reflex for 2 hours. So what will be the product in this reaction? So if you look at the stepwise mechanism for this reaction, the phosphorus has the lone pair of electron. So this lone pair of electron in the first step attacks on this position, and the bromide get eliminated. So the first step will be ethyl double bond O. So here there will be the phosphorus. So and which has the ethyl, sorry, the O ethyl side chain. I will not draw fully that one. So this is the product. So now the phosphorus have the positive charge. And if you look at this bromide, which is the Br negative, eliminated, which now can attack on this phosphorus. But instead of attacking directly on the phosphorus center, it attacks on the. So we have this ethyl group, right? So this ethyl group, I will just write down in the one of the chain in the full form. So this will be CH2, CH3. So this Br negative now attack on these uh, CH2. So this will be O negative, which the now will be involved in the P double bond O formation. So directly I will draw that step, and this positive charge will be gone now. So what will be the product? O ethyl double bond O. This is the phosphorus, and here there is a phenyl ring which has the O ethyl substituent, and now since it is P double bond O, so that will be like this. So this will be the product in this reaction. That's the phosphate. So if you want to the full reaction mechanism, so you can refer this slide. So which is just saying that I have explained here. So the first step. So that's the first step, and this is the second step. So you can refer this slide. or note it down. The concept is the same that I have explained. The first attack is the on the CH2. So Br minus is eliminated, and this eliminated Br minus now attack on the one of the ethyl chain. It gives the formation of P double bond O. So this is just the bracket P double bond O means. So this will be, I just draw the full. So this will be the same. So that's the product formed in the reaction. So we have the next question, which is major product formed in the following reaction. So if you look at the starting, so whenever you going to solve any question, so always look at the startings, observe the startings and the reagent. So in this startings, what are the starting materials we have? This is the P double bond, CH2, P double bond, CH2, C double bond, P, PH3. That's the Wittig salt. And here we have the aldehyde. And we know the reaction of Wittig salt with the aldehyde. So whenever we have the any Wittig salt, there are two types of Wittig salt. Let's say this is CH3, CH double bond, P, PH3. And there is another type as mentioned here. That's the ethyl. So that's the Wittig salt of the ester, P, PH3. So these are the two types of Wittig salt. So this is the unstable Wittig salt, and this is the stable Wittig salt. And this Wittig salt we always prepared in situ. So from which starting we prepared this Wittig salt. So CH3, CH2, P, PH3 plus. So when you add the base, let's say NH, so I had right, it abstract the one of the proton. So it's the proton which get abstracted, and in place of the base it gives the formation of this Wittig salt CH3 CH2 PPH3. That's the unstable Wittig salt. And so this Wittig salt, once it form, we it then react with the aldehyde or the ketone in the reaction, it form the olefin as a product. And in this example we have the Wittig salt with the uh, this group is the ester. So this is definitely a stable Wittig salt. And this stable Utic salt, why this is stable? Because if you look at the delocalization of this double bond, so how it will be? The resonance structure of this will be the C H negatively charged followed by P PH3, which is healthy positively charged, and this is the OET, it's the ester part. And this salt get stabilization, this negative charge, due to the delocalization into the carbonyl group of this ester, right? So this is the stability, and always remember, whenever we have the stability salt, it always form the E as a alkene, E alkene as a product. So the stabilized Wittig form E alkene, and stereochemistry of the carbonyl compound remains unchanged. So that's the answer for this question. So look at the structure, core structure. So this all part will be remains same. Now at this position, it forms from this CH2, this CH2 also remains same. So I will just so this entire part along with the carbon will remain same from this Wittig salt, and so from this aldehyde compound, and this part from the Wittig will be remain same, and just there will be a double bond formation between this carbon and this carbon, right? So look at the options that we have available. So in the option they have added this with this sorry Z geometry, which is incorrect because in the starting the geometry is E, right? But here the geometry is Z. So that's why this is the wrong option. In this also they have mentioned here the uh, Z geometry, but in the starting it was the E geometry. The option B and D are the incorrect options. So we have neglected two options. Now we have the options A and C. So if you look at these up to here, so which is both is okay. Now the question is the product after the reaction. Now we have performed the reaction on the stabilized Wittig salt. So we should get the E geometry, right? Because stable Wittig always give the E geometry. So E means like this manner, and Z means like this manner. So this can be any group. E, you can consider E as a trans and Z as a cis. So this should be the product which has the E geometry, right? So option C is the correct option here, which has the E geometry in the product. So this is how we can solve the question from the VT. So I will take one more question from the same VT concept. So better I will take here also here only. So just perform the same reaction. Just change the Wittig now, Wittig salt now. So let's say instead of this Wittig salt, now I have the, so instead of this Wittig, let's say I'll just rub all this entire structure. Instead of this Wittig, I have CH2, CH2, P, CH3 plus. And in the reaction, uh, so there is sodium hydride, TH, yep, 0 degree Celsius. So this is the reaction condition and what will be the product. So ignore these options. So what will be the product in this reaction? So we have this aldehyde that will be remain same. So I will draw that one first. So this part will be remain same, and up to here also this carbon also it will remain same. And now we have the this part from this Wittig. So due to the sodium hydride, it forms the internally Wittig. That's the CH3 CH double one PH3. So that's the Wittig activity salt and it react with these aldehyde. So it will form the hydrogen will be also remain same. It will form uh, this product which is has the Z geometry. So I hope you able to solve the question from the Wittig now. I will take the next concept, which is this is now the question of this. This is one of the name reaction. So yes, we have the benzene ring, which has the N double bond N double bond N. This as a group. This will be the positive and healthy negative charge. And we have added the PPH3 THF. This was the first reagent combination, and the second one CH3 CO2H. That's the acetic acid. So what will happen in this reaction? So when you react with the N3 with the PPH3, so always note down what are the reaction center. So in this reaction center, if you look at this one, it has this positive charge, which can be, and it has the negative charge. So this negative charge can go here, and this bond can go this solution. So how this will be look like? So this will be now the N negative followed by the N, triple bond N, in this manner. And the PPH3 has the lone pair of electron when it attack at this position. So this will enter into group will be eliminated, and which will form now here. I'll just draw with this one N negative and this PH3 positive. So this is the intermediate is formed in the first step. And when it react with the acetic acid, so what will happen? So I will take the next blank slide. So right, so up to here we have formed the this intermediate. Now when we react with the acetic acid, so that's the OH, right? So right, when we react with the acetic acid, what will happen? This O negative can attack on the phosphorus, and so before that one, before this attack, there will be a one step that I will explain first. So this N negative and the P positive, so it can form, it can be in the another resonance structure form. So that's in the form of N double bond P. So now both these nitrogen as well as phosphorus are neutral. This O negative from these acid is now the lone pair available for the attack. So this the attack on the phosphorus followed by the negatively charge will form on the nitrogen. So it will form intermediate like this. So the N will be the negatively charged. Now the phosphorus which has the, so this is the part of this entire part is from the acetic acid, and here that's the pH3 will be remain. That's I will draw with the in the bracket. Right. So up to here, I hope it's okay. Now this negative charge can attack on these because this is now electropositive because of the proton. This negative charge on the nitrogen can attack on the acetic acid, so which further leads to the formation of, and this bond can be cleaved. So this will lead to formation of this the benzene ring with the nitrogen which has now the CH3 acetic acid in the center, and the phosphorus is now will have the P double bond O because of this bond. This phosphorus will now become P double bond O, and the pH3 will be remain same. So this is the product form in this reaction, and further uh, elimination of these upon protonation, the P double bond O pH3 can be eliminated, and which leads to the formation of amides. So that will be, so if you look at in this product, so we have the acetic acid, that's the source of proton. So in the reaction, which is so which can induce the formation of, so this bond eliminated, it forms this pH, the benzene ring. I will draw in the shortcut. So this has the so this is the product is formed, and the P pH 3, and which has the double bond, so will be eliminated. So the stepwise reaction mechanism, if you want to see, which is here, much clear than the that what I have drawn. So the first step that as I have explained, so it forms the when it react to the PPSD, the N2 elimination takes place. So it forms the N double bond P PS3 intermediate, and which then react with the acetic acid. So acetic acid, the O negative of this lone pair of the acetic acid attacks on the phosphorus. So it forms this intermediate followed by internal rearrangement. That's the N negative attacks on the acetic acid carbonyl center of the acetic acid, then the P double bond O formation. So these two bonds formation takes place, and then further P double bond O PS3 elimination gives the formation of this amide. So throughout this reaction, the first step you need to understand, remember, whenever we have the N triple bond, sorry, N plus PPH3, it leads to formation of N P double bond O, sorry, N double bond PPH3. So that's the product formation in the first step, PPH3. And when you add the acetic acid or any acid, so that can be, so that can be the part of, so NPH and the blonde O. These are any acid, so whatever are C double bond O OH, whatever are present in the acid, so that will be remain in the product. So these are come from the part of the acid that we used. So similar way, if you use the if I give the reaction, so when you have the so any substituted benzene ring which has the N, and we have added the first step is the pH 3, and the second step is the any RC double bond OH. So in this reaction condition, we get the formation of NH double bond O R. So this R from this group, and this entire group will be here. So depending upon any substituent, so this is how you can generalize the reaction, and you can perform the same reaction on any kind of substrate. So I hope this question is clear. I will take the next question. So which is again on the Wittig reaction. So the question is, what is driving force for the Wittig reaction? So whether carbon-carbon double bond formation, or P double bond O formation, or P double bond C bond formation. So in this case, P double bond O bond formation is the driving force for the Wittig reaction. So if you look at the Wittig reaction mechanism, so let's say we have the aldehyde, and we have the Wittig salt. Let's say the R dash C H P pH 3. This is the plus, and this the sorry, this is the negative, and this is the positive. So in the reaction, so we get the R double bond, whether it is cis or trans. R dash, R, um, R dash, anything. Along with this, we get the P double bond O PH3 as a side product. So that's the POPH3, pH, pH. The pH is from as a side product and which is driving force for the Wittig reaction. So for the better understanding, just search the, just have a look at the, I will give the work for you. So mechanism, Wittig reaction. So Wittig reaction mechanism, you need to have a look. So you will understand where this P double bond formation is takes place in the reaction mechanism. So this is the another question. So most stable carbon ion among the following. If you look at the carbon ions, so this is the PHS CH2. That's obviously unstable carbon ion compared to the others because they have other are the S double bond O groups. Then the question is, we have the two S double bond O groups here, and here there is one S double bond O group. So again, so better I will draw in the, I mean, the manner of stability order. So the A is the least stable, then the B. Now the question regarding C and the D. So in these two, obviously it has the benzene ring, so which again gives the stability to the, so sulfoxynium stabilize the carbanion is the most stable one, and presence of the phenyl ring makes the option D, that's the one the most stable compared to the option C. So this is the stable carbanion compared to, so option D is the correct option here. So the most stable carbanion is the D, which has the S double bond O CH2. Oh, sorry, the pH group. So I think this type of question we have seen in the last video when we are discussing regarding the pKa values. So I will take the some of the more questions. And the first question, I think this question I have already covered in the uh, so there are some simple questions that I will just put it here without any discussion. So better just for uh, to, it will help you to solve some of the assignment question. So this is the first question. So these are like based on the oxidation, and so here which reagent used in the Peric Doring oxidation reaction? So to activate DMSO, which reagent is used? So that's the SO3PY iridium, SO3PY reagent is used for activating the DMSO in this reaction. The next question, I just put it here on the Pitzer-Moffitt oxidation reaction. And so in the Pitzer-Moffitt oxidation reaction, the reagents are the DCC, pyridine TFA, and the solvents are the DMSO and the toluene. So I will take that question here. So this is the question. So the major product formed in the following reaction. So we have the diol, 1,2 diol, and the reagents are the DCC and PY, pyridine TFF in the DMSO. So in this oxidation. So we know alcohols are converted into the diol. So this one is the correct option here. So here they have shown the bond cleavage, which is incorrect, and this oxidation. So here the equivalent not mentioned. So obviously we need to consider it is in the uh, excess amount. So there will be a complete oxidation of this oxidation reaction takes place in this step. So the option A is the correct option here. Then the just also have a look at this type of oxidation reaction, the mechanism of this oxidation reaction, which is already covered by the professor. So I don't think we need to discuss in more detail here. So I will take the some questions from the based on the oxidation reaction. So here is the first question. It's not really oxidation reaction. So here, better I will show this question. Right. So this is the question. If you look at we need to identify the major product. And if you look at the starting material, which has the hydroxy group and the NH2 group, and the reagent is the NaNO2, NaNO2 in the dilute HCl, then the dilute HCl. So what will be the product in this reaction? And so to solve this question, we need to go step by step manner. So what happen when this group react with these NaNO2? So the hydroxide group will be the remain inactive, but the NH2 group convert into the N2 group. So we have seen this many times. How these so here among these hydroxy will be remain as it is, but the NH2 group convert into the N triple bond N group N2 group. Now this will be the positive charge, and it is a kind of good leaving group now. And what will happen now? So we have the hydroxy group, and on which at alpha position there is a N2 group. So the lone pair on the hydroxy group goes here, and there will be a 1-2 migration of this bond takes place. So it will leads to formation of now the ring opening takes place. So this will be now O plus this will be now six member ring, and this N2 is now eliminated. So this is how we get the product, and then followed by the minus proton. So it leads to the formation of option B, that's the B product formation. So that was this was the two-step reaction. The first step is the conversion of this N2 to conversion of this N2 to NH2 to N triple bond N, and the next step is the 1-2 migration, 1-2 bond migration. So which leads to the formation. And what is the driving force for this 1-2 migration? So this lone pair on oxygen involved in the double bond formation with this carbon and oxygen, and therefore this bond migrated to the second position, which has the good leaving group, that's the N triple bond N, which has the positively charged. So this good leaving group, because of this one, so this N2 group entirely eliminated, and this 1-2 migration takes place. So we get the option B as a major product in this. And if I just put the detailed mechanism also here for your understanding. So you can refer this mechanism. I will just put the clear slide. So right, so this is the mechanism. You can refer the slide. Then there is one another question on the similar manner, and which is based on the Hofmann rearrangement. And I hope you have studied the Hofmann rearrangement reaction. So you will not find any difficulty in solving this question. So here is this question. So in this question, if you look at the starting material, we have the amide. So this entire group, you can consider this entire group as a R double bond O and H2. This is the entire group. And when it react to the Br2, what will happen? So R double bond O N H Br. Right. So in the Hofmann rearrangement, the reagent is the Br2, NaOMe, and the methanol. So this is first bromination. Then the base abstract the proton. When the base abstract the proton, it forms the negatively charged here. So that's the R double bond O N and the negative charge here, which has the Br, and which then further this bond elimination. So the nitrogen formation, and this entire group now migrate to the nitrogen. So when this lone pair involved in here, so entire R group is migrated here. So it leads to formation of O double bond C double bond nitrogen, and here this entire R group, which further leads to the formation of. So when what do you have in the reaction? We have the solvent methanol. So this methanol is the nucleophilic, and this if you look at the active center here, so this carbonyl is the active center. So in takes place here, and it leads to the formation of. So I will write here R. That's the N. That's the double bond O, and here O ME, and then it get the proton from the solvent. Obviously, the methanol, the proton from the methanol. So this is what the product we get. So this entire R will be the cyclohexyl ring. So what will the product in this one? So this is not the product. Yeah, option B is the correct. So this R N H C double bond O yummy. So that's the product formation takes place in this reaction. And so you should able to solve this question if you just if you are aware about the Hofmann rearrangement reaction. So which has the nitrogen intermediate formation. Similarly, there are several reaction with the carbene intermediate, and like Curtis rearrangement reaction. So which has the carbene intermediate formation. Then uh, this is the assignment for you. So identify all the rearrangement reaction and identify which which intermediate is formed in this reaction. So intermediate in reaction. So the first one is the Hofmann. Same, the second one is the Curtius. Third is the Baer-Villiers. Fourth is the Simon Smith, Riemann Timan, Wolf rearrangement. So they are the Riemann Timan. Then Wolf rearrangement. So in this rearrangement reaction, whether the carbocation intermediate formation or the carbene, nitrine, carbanion. So these sort of intermediates are involved in this reaction. So identify which reagents, which intermediates are involved in this reaction. So this is assignment for you. I will take one more question before closing the session. So, which is again based on the alpha beta unsaturated carbonate. And I think this is the question from the topic, which I think we have already discussed also prior. So this is the question, and what will be the product in this reaction? And so this is the copper salt. We need attack on this alpha beta unsaturated carbonate. But keep in mind, while solving, you need to also pay attention on this stereochemistry of methyl group. So what will happen? This methyl negative attack at the 4 position, and this is how the intermediate formation takes place. O negative. This is the methyl, and this attacking methyl will be from the downside. And obviously, the next step is the formation of abstraction of proton. So we get the product, which is, so option A is the correct option here. Uh, and in the same manner, instead of this copper, when you add the grignard, so there will be that different product. So which will be looks like this. Okay. Right. So this was the problem for today. So do you guys have any doubt regarding the questions, whether it is from the assignment or anything? We can discuss it now. Uh, Sorry, you was not audible. Can you?
In the Schrodinger reaction, if we use water instead of acid, what will be the product? The product will be amine or cyanide.
Schrodinger reaction. So I need to look at the
We have already discussed about this question taking acidification by acid.
uh, just I will just go to the question. I think, yeah. So this is the question, right?
Yes, sir.
Right. So in this question, so up to here is okay. I will just take the new slide. Right. So in this question, so whenever we have the reagent pH N triple bond, sorry, N double bond N, and this will be the negatively charged, and this will be the positively charged, right? So
Right.
whatever the nucleophile here, the nucleophile is the acid itself. So this is as a nucleophile. But if you add the water, that's the your question, right?
Yes, sir.
So when you add the water, so what will happen? So I will just draw the again the possible. So this will be N. This will be triple bond N. Now this will be the positively charge, right? So this is the and this is the resonance structure, right? So that's the same. Now when it react to the, I think directly we can start from here. The first step will be the same, which is again the this intermediate formation, right? Up to here is the same. Now we have the, instead of this carbonic acid, we have the water. So the water will attack on the phosphorus, and this P triple bond N pH, and we have the three phenyl rings. So phenyl groups on the phosphorus, that will be remain same. The the lone pair of water attack on the phosphorus, and this reaction get quench in this form. So this PO, so this will be the H. So the pH will be remain there as it is. Now the end, this negative will abstract the proton obviously from the water. Now this will be like this. So one of the proton is abstracted, so we can write in this fashion. And now again we have the oxygen lone pair, so that can involve here, and this bond also get cleaved. So right, so your answer is the correct one. It will give the sorry, not the CHNH3, NH2. It gives the amine. So the product we get here, the amine one, right?
Sir, sir, please explain question number 3, assignment 11.
Right. So from the current assignment, right? I will just open the portal. From the assignment 11, right? This is just a simple example of the
Equal
substitution
elimination.
reaction. Right, exactly. The elimination or substitution. That's the question here. So I will take it on the new slide. So is this is the question, right? So in this question, if you look at the reagent, we have added the POCl3, and I hope we have well aware about one of the reaction. So when we have the R and we have added the OH, CH3, let's say any R group, and when we add the PBr3 and the pyridine, so we observed the inverted in the stereochemistry that the product bromination Br CH3. This is one. But in this question, we have the POCl3. So that's the P double bond O Cl Cl. And the starting is the alcohol and the pyridine. The pyridine, what does do? Pyridine. So this is the
Pyridine
R.
is a base, but it will
Yeah.
abstract proton from OH,
Okay. Yeah. So it
and
will
it will
become,
form double bond.
right. It will form O negative first step here, and this is the CH3 remain. So this O negative now can attack on the uh, phosphorus center, and Cl minus is eliminated. So it basically it will form the this R group. That's the cyclohexyl chain that I will just draw as it is. The O, P double bond O, Cl and Cl. So this is what intermediate we get in the reaction. Now the question is, uh, what will happen with this intermediate? right? So this is the intermediate we get in this reaction. And so when we add we have the Cl negative in the reaction, the pyridine is in the reaction, right? So
Right.
there are two possibilities. So this is the CH3. This R group is the, I will directly draw the entire structure now. This was the R group, right? So which has this group. So the Cl negative can uh, attack on this position. So this entire group will get eliminated. So this is the one possibility, and we get the inverted in the configuration, the product with the inverted configuration with the Cl group. That's the Cl. Because if you look at the starting, which has the OH directing beta, so the product might be uh, so this might be the product which has the Cl directing alpha, that's with the dotted line. The second possibility, as you mentioning, the elimination reaction. So, what will be the driving force for the elimination reaction that we need to identify? So, if you look at the pyridine, so pyridine is not that much strong to abstract a proton. So, in this case, so how the reaction will go if the pyridine abstracts the proton? So, this was the first product that the in the fashion of SN2 reaction, right? So now you are mentioning either E2 elimination, that is the abstraction of one of the proton. So I will just rub all these earlier one. So we have these proton here and here also. So I will just draw that one, CH2, and this is the one proton we have, and this is the one proton that we have, right? So among these two protons, we'll just take one more proton, right? Among these two protons, which proton is easily abstractable? Because the pyridine is the kind of bulkier comparatively, right? So this lone pair itself, we need to abstract the proton. So whether it abstract this proton or whether it abstract this proton, so that you need to identify. And as you mentioned, the E1 elimination can also possible by which manner? So whether this entire group is eliminated and what will form? It might form PWO, O negative, then the Cl, but that's not the stable case with the phosphorus for PWO also. So this will be the O negative, right? So this can eliminate it. It can form the CH2. This is the carbocation. This is the product by E1 elimination, right? And by E2 elimination, this is what that we are mentioning by E2 elimination. That is involvement of both base as well as the starting material. So either it abstract this proton or this proton, and it leads to respective product formation. The products might be, let's say, abstraction of the proton followed by these stable double bond formation. We get this one, and another option is the action of terminal proton to get this product. So these are the total three possibility. And so this might be also a product. Let's say I will label it as a B. So this was the A product. This was the B. This is the C. And from this also we can get uh, the same among these to be B and C product, right? So either then elimination of this proton or elimination of this proton can lead to the formation of respective two different products. So, but the pyridine is not that much strong base. So I believe this elimination doesn't take place. So we get majorly this as a product.
Sir, as it is a secondary alcohol, it will proceed through SN2 reaction, and the stereo inversion of inversion of which will occur. Cell will attack in the lower side.
Right. So most likely option C is the correct option, I think, right? Because these
Okay,
products
sir.
are from the uh, elimination, right? Elimination reactions, these products.
Uh,
And this is from the SN2, and this is from again, but to retain the stereochemistry, that's difficult here because the intermediate, as mentioned here, so this was the intermediate. And from this intermediate, the retention in stereochemistry is, I don't think, will be the feasible because there is no any such transition state involved can give the retention in stereochemistry in the configuration. So the option C is the correct option here.
okay, sir.
In the same assignment, there are like simple questions. So the fourth question is also same, just on the we have added the DMSO and auxiliary chloride. So it's just oxidation reaction, Swarn oxidation reaction, right? So you
Or
should
no
able
oxidation.
to click. You should able to click the correct answer. The question five answer that I have already discussed because I thought that is somewhat difficult. So I have discussed that one first. Then question six is the just oxidation by the PCC followed by the Wittig reaction, and make sure
यार
this is the step.
यार जो इलाइड फॉर्मेशन हो रहा है वो
Mhm.
स्टेबल इलाइड होगा.
Exactly, that will be the stable yield, and you get the E as a product. So what will be the product? E. So option B is the
डी.
yeah. In the option seven also, oxidation state of the phosphorus that we need to identify. That I don't think difficult. Then the DMF and the POCl3 already discussed. The question 9 is based on the major product forming the following reaction, and you have given the N3, PPH3. As you mentioned, I think we have discussed this question also.
आंसर
It
सी
gives the
होगा.
yeah, and then the question is based on the question 11. So we have the alcohol and the acid, and we have added the PPH3 and DIAD. So this PPH3 DIAD combination is useful for the coupling reaction, right? So that you should able to solve this question. If you just look at these all the questions, that I think all type of questions that we have already covered.
ओके सर.
Yeah. The question one and two is also same question, similar question. The structure of POCl3. So that I think you should able to solve that one. Then question two is the write down the major product following the formulation. And here that I have discussed PBr3 reaction. So the Br minus attacks and we get inverted configuration product. Question three that we have discussed. Here we have given the POCl3. Just in this question, uh, I suggest to look at the more any similar problems because if you look at the question two and the question three, in the question one, question two, there is PBr3. In the question two, it is POCl3. So the mechanism most likely may be different. So this will be not that much easy to click on directly option C. You need to find out the possibility to form option D as well. Sorry, option B as well. So option B can also be the product. So I also need to look at this product now because it's quite confusing. So as you mentioned, the elimination can also possible. So we'll stop here for today.
अच्छा.
Yeah. So thank you for joining, and I will upload all the this video and this slide in the OneDrive, so you can download it from there.
थैंक यू सर.